All right, we're on the 11.4b worksheet. Number one, we're going to list all the factors of this monomial. So factors are the whole numbers and variables that can be multiplied into this to create a 21. So we have, if we start with just the regular numbers, we have 1 and 21, and we have 3 and 7, because 1 times 21 is 21, and 3 times 7 is 21. Now, we have to deal with the x as well. So first of all, there is an x. We could factor out an x, or an x squared, or an x to the third. And then from there, we could take a 7x and a 7x squared and a 7x to the third and a 3x, on and on and on. So we need to list all those if we're doing this. So 7x, 7x squared, 7x to the third for each one of these. Now, these ones right here already actually have the 1 in front, so I don't need to repeat that. 21x, 21x squared, 21x to the third, and then 7x. Oops, I already did 7. 3x, 3x squared, and 3x to the third. So I could take every single one of these and multiply them by one of these other factors to create this. All right. Number 2, got 1 and 6 and 2 and 3 and y and z and yz. So those are my different combinations of variables that could be factored out. And then each one of these numbers, this would be 1 already, could have these. So you could have a 2y, you could have a 2z, and you could have a 2yz. And then the same thing for 6, 6y, 6z, 6yz, and the last one, 3. 3y, 3z, 3yz. All right. Number 3, now we're going to find the greatest common factor. So this was the list of all the individual factors of this term. We could do that again for 3. We're not going to, but we could. And then do it again for the 24m squared n. And then we're going to look at those two lists. Now we're not actually going to list them all out, but you would look at those two lists and find anything they have in common and look for the greatest common factor. So the largest number, whole number, coefficient factor, as well as the largest power for one of the variables. So the easiest way and the fastest way to do this is to start with the smaller of the two coefficients. Think about those factors and if any of them actually fit into the other one. The reason you don't want to start with the big one is a factor of 24 that I could consider is 12, but 12 is never going to go into 3, or 8, never going to go into 3, or 6, never going to go into 3. So if you start with the small ones, you'll get to it faster. So 3 only has 2 factors, 3 and 1, and so 1 is pointless. That's not going to help us. And so 3 is going to be our best bet here. So 3 fits into both 3 and 24. Now, I can't factor out an n because this one doesn't have it. I can factor out an m, and I need the largest common factor. Well, m squared does fit into both of them. Not n to the third, because while it would fit into here, I can't factor out m to the third on this side because it only has m squared. And so that's the greatest common factor. So 12 and 8. Go to your smaller one. 8 and 1, not going to work for 12. So 4 and 2, 4 does work. 4 fits into 8 and to 12. And I see I'm going to have a p, and the smallest p available is just p to the first. And I have an r on both of these. And the most I can take is squared. Number 5. Got these two. Oh, I almost missed this one. I'm thinking this was one big term. There's 3 of them here. So 15, 6, and 18. So starting with 6, think about my factors. 6 would work for 18, but doesn't work for 15. So 3 is going to be the magic number that fits into all of these. And these two have an S, but this one doesn't. So I can't pull an S out of all 3. This one has a T, this one has a T, this one doesn't. So I can't pull a T out of all of them. And so for these 3, the only common factor they have is 3. In number 6, 20, 28, and 8. Start with your smallest. You've got 8, but that doesn't fit into these. So again, it's 4. They all have a V, The smallest out of them is v to the second, and so that's the most I can pull out. And then they all have a w. This one only has one, and so that's the most I can pull out. Sliding down. So these are halfway factored. They've already pulled out the number, and we're just going to complete this binomial or trinomial in here so that if I did go back and redistribute, I would end up back where I started. So 3 times something is giving me 9c. That would be 3c. 3 times 3c is 9c. I've already got this minus sign, so 3 times this missing number gave me 21. That would be 7. All right, here they factored out a 17d. So what did they multiply by to get 34d squared? So you're actually dividing these if you want to plug it in your calculator. This will go in twice. And now if I just multiplied this, I'd get 34d, not d squared. So I need another d here to get to my d squared. And for this one, 17 goes into 51 3 times. So if I did 17 times 3, I would get 51. And I already have this d, so 17d times 3 will get me here. I don't need to add any more d's there. Okay, 7. 7 times something is 42. That's 6. I have squared, and it became to the 5th power. So I need 3 more to get me there. To get to 28, that's a 4. I already have c squared. Got to get to c to the 3rd, so I need 1 more c. And to hit 35, and actually this, I just caught that, it was a plus 28. And right now I already have a minus here, so it would have to be a negative 4c to create that positive. So just be careful there. That's a little tricky. Not too concerned about that. And then here I'd be multiplying by 5. They've already got the minus sign there, so I'm good. And c squared is already there, so I don't need to add any more c's. Okay, number 10. 22 was factored out, so I'd be multiplying by 1. If you want to put the 1, you can put the 1. And then I have an e. I'm going to multiply and end up with e to the 4th, so that means there's an e to the 3rd right here. Now I got to create a negative. And to get to 44 from 22, I'm multiplying by 2. And when I do multiply, e goes to e squared, so that means there's one more e here. Times and you get 66, that's 3. I've already got the e, so I don't need to add any more. 11, factoring out a 5. So this is going to be a 1. F squared goes to f to the 5th, so it's f to the 3rd. 5 times something gives me 30, that's 6. F to the 2nd becomes f to the 4th, so there's an f squared here. And then 5 goes into 10 twice. F to the 2nd doesn't increase, it's still f to the 2nd. And so I'm not going to add anything here. Okay, number 12. Out of this trinomial, those 3, common factor of 3. So 3 times what gives me 15? That would be 5. G to the 5th became g to the 7th, so there's 2 there. 3 times what gives me 9, and the minus is already there, so I don't need to add it. So that would be 3. G to the 5th just becomes g to the 6th, so there's just a 1g there. And then here, it's 3 times 8, and g to the 5th doesn't change, so we have not added any more g's. All right, 13, pull the 9 out, so it's times 2. The a became an a, so I don't need to add any. B became b squared, which means there was a b here. Okay, 9 to get to 27 is being multiplied by 3. A becomes a to the 3rd. So that means there was 2 more being added on, and b stays b, so we don't want to add any more. Next one. 4 is coming out of 16, so it's 4 times 4. Squared becomes squared, no change. Squared becomes the 4th, so there's 2 more. 4 is being multiplied by 10 to get to 40. X squared becomes x to the 3rd, so I have an extra x being added. Y squared becomes y to the 5th, so y to the 3rd is added. So again, remember, we're trying to get to this. It's like working backwards. You can always double check yourself. Multiply this times this and make sure you end up back where you started. Okay, here. Factoring out a 7, so it's times 2. M to the 3rd power, I need m squared to get there. n squared becomes n squared, so there's no n's there. Oh, I'm sorry. It's n to become n squared, so there is an n there, one n. N times n gives you n squared. Okay, this would be times 3 to get to 21. To get an m squared, I need another m. The n hasn't changed, so that means there's no n on this term. To get to 35, it's 5. The m's match, the n's do not, which means this was another n. N times n is n squared. 16. 3 is factored out, so that's a 2. R to the third became R to the fourth, so there's 1. S to the sixth became S to the eighth, so there's 2. Minus is already there. It's times 5 to get to 15. No R change. S changed by 1, so I need an S. Multiply here. It's 10. The minus is already there. 3 became 5, so there's 2 R's. 6 stayed a 6, so there is no S. Last one. 4 goes into 32 8 times. The U went from 4 to 5, so we added 1. V went from 5 to 6, so we added 1. This term right here matches this one. That means we're timesing just by 1. Over here, we times by 2. 4 became 6, so there's 2 more U's. And then 5 became 7, so there are 2 more V's. All right, to the back. So I'm actually going to come back to these. I think that'll help. Let's start by factoring these bottom ones because we need this skill to do those. So I wish they would have actually gave this in a different order. So on 24, now the answer in the answer key is actually not completely factored out. So it's actually an incorrect answer here. So they factored out a 2, which you can do. But anytime you have even numbers, you could factor out a 2. We want the greatest common factor to factor it completely. So you can see their answer. They factored out a 2, but the problem is 21 and 6, that can still be factored. You're not factored completely until you've got this binomial or trinomial, whatever it is, and it can't be factored anymore. 21 and 6 can be factored by 3, okay? And so this is not fully simplified. So when I look at these, I need a number bigger than 2 to get me there. Well, 3 is going to go into both. And if 2 and 3 both go in, that means 6 goes in. Okay, so 6 can go into 42 and to 12. So I'm going to factor out a 6. 6 times what gives me 42? That'd be 7. And I need to add an E on that. So I get 42E when I multiply 6 times 7E. This would be a minus, and then this would be 6 times 2. You can always double check. Now 7 and 2, can't factor anything out. So I know that this is completely simplified. All right, next one, answer key looks good. 77 and 14, you can factor out a 7. Now notice I'm not factoring out a variable because both terms don't have a variable. You can only do that if both of them have it. Both of these have a 7 inside that I can factor out. 7 times 11. F to get 77F and 7 times 2 to get 14. 25 and 70, you can factor out a 5, and they both have a G, and they actually both have a G squared inside of them. So we got to get the largest exponent we can without going over one of them. All right, so it's 5 times 5 to get 25, and the G squared is already there. I don't want to add any more G's here because then I wouldn't get G squared, I'd get a higher power. To get 70, 70 divided by 5 is 14. And this is G to the third. So I do need to add another G here so that when I multiply, I get here. Okay, 27. Out of these two, you should try 6, you should try 8. Okay, but the largest number that's going to go in is 4. And they both have an H. Smallest of them is H to the 5th. So 52 divided by 4, that's 13. And I need to add 3 more H's to get me there, to get from 5 to 8. Minus 4 goes into 24 6 times, and I've already got H to the 5th, so I don't need to add it onto this one. Okay, 28. When I see these two numbers, I think 9. I know that 9 goes into both of those. And there's a bunch of i's I can cover out here. That would be 7 of them. That's the smaller of the two. So I'm only multiplying by 8 here. If I do that, I get here. I don't need to add any variables, any powers. Minus, this is times 3. And to get from 7 to 10, I need I to the third. Okay, 29. You might say 8. If you do, you won't fully simplify in your first shot. Okay, 16 is the greatest common factor here. Both have k's. The most k's I can take at a time is 4. And they both have m's, and the smallest of the two is 3. So it's 16 times 3 to get to 48. I need 2 more k's, and my m's are good. I don't want to add any more m's because I've got m to the third. Times 2 to get to 32. My k's are good. I need 3 more m's though. Okay, number 30. 12 and 36. 12 does go into 36, so I can take a 12 right out of this. They both have n's. 3 is the most I can take. They both have p's. 3 is the most I can take. So this would be times 1. I need 6 more n's though, and I need 2 more p's. 12 goes into 36 3 times, and I've already got n to the third and p to the third, so it is just a plus 3. 31. Those numbers, when you look at it, 55, 44, 66, 77, 11 is the factor that goes into those. I've got a q, the most I can take is 1, and r, and the most I can take is 1 because of this one. So this is times 5. I need 9 more q's. I don't need any more r's to get here. Minus times 4 to get to 44. Q's are good. I need 9 more r's though. 32. Looking at these, 60, 36, 30. 6 is the biggest number that fits into those. And they all have some s's. So the most I can take at a time is 2, because this one only has 2. So now I'm going to have 3 terms in here because I've got a trinomial. So it's times 10 to get to 60. Don't need any more s's. Times 6 to get to 36. I'm going to need 2 more s's to get to 4. And this is a minus times 5 to get to 30, and I need 4 more s's on that term. All right, out of these, kind of a tricky one. So when you look at these, at first I was thinking 13, but that's not going to work for these. It's actually 23. Now on the quiz or the test, it's not going to be that difficult. It'll be smaller numbers, be a lot more obvious. But 23 does fit into all of these. They all have a u. The least amount is 2. They all have a v. The least amount is 4. So it's 23 times 3 to get here. I need 1 more u, and I need 1 more v. It's times 2 to get to 46. I don't need any more u's or v's. And then this is times 1 if you want to write the 1. And then I need 1 more u, and I don't need any more v's. All right, out of these two, I can factor out a 13 and some y's. The most I can take is 4. So it's 13 times 1. I'm not going to write it this time. I need 4 more y's to get to 8. It's a minus. It's times 2. And I've already got 4 y's, so I'm not adding any more. All right, out of these here now, I can take out 14, 28, 21, a 7. Looks like they all have at least 1 b, and they all have some c's. Most c's that I can take, because I can only take 1 b because of this right here. The most c's that I can take is 2. All right, so it's times 2 to get to 14. I need 2 more b's to get from just b to b to the third. And there's my 2 c's, so I'm not adding any. Multiplying by 4, negative 4, to get to 28. 1 more b, 1 more c. To get to 21, it's 3. Don't need any more b's to get there, but I do need 2 more c's. All right, so now up to the top. We're going to use those same skills to help us simplify these fractions. So what we're going to do is we're going to factor out the top, and then we're going to cancel it with the bottom. So one common misconception is that people want to just cancel these, right, and just be left with 26 w to the 6, but that doesn't work. That'd be like telling me that 5 plus 10 over 5, I can just go like this and say, oh, it's 10. That's not equal to 10. 5 plus 10 is 15 divided by 5 is 3, right? You can't just cancel that out. So we need to create a product. If we have 5 times 10 divided by 5, we can cancel those. So the answer is 10. 5 times 10 is 50 divided by 5 is 10. So that does work. So if I can create a product here, which is what I've done here, multiplication, I can cancel things. And so the bottom of these is kind of giving you a clue because these are simple of what you can factor out. So you can kind of cheat a little bit and try and pull out this number from the top. But let's just focus on the top for now, and you'll start to see the pattern there though. So out of these two numbers, 13 and 26, I can factor out a 13. They both have w's, and the most I can take is 3. So what am I left with up top? Well, to get this first term, I only need to multiply by 1. It doesn't change. To get to the 26, I need to multiply by a positive 2, and I need 3 more w's. Now, replace what's on the bottom, and notice that it shows up here and here. So these can cancel to help us simplify, and we are just left with whatever's on top. 1 plus 2w to the third. Now, at the beginning of this lesson, and you can see in all of these, the leftovers are always going to be on top here, but that's not all the time. So let's say that this was just flipped. The 13's canceled from the top and the bottom, and you were left with this on the bottom. Then you'd have to put a 1 on top. So you'd do 1 over 1 plus 2w to the third. So if it was left over on the bottom, you can't just now bring it up to the top and make it a whole number. It would stay a fraction like this. I'm not going to see that today, but you will see that come Monday. All right, 19. Again, you can kind of cheat. This is what I need to get out of this. So a 7 is coming out, and I've got x's, and 4 is the most I can take. You can see that will cancel out the bottom. So what do I have left over here? So I'm timesing by 10 to get to here, and I need to add 5 x's. And to get to 42, I'm multiplying by 6 with some x's added on. So these cancel, and I'm left with this as my final answer, 10x to the 5th minus 6. Okay, here, now this one can be a little tricky because of the negative. If you were just looking at the top here, you'd never think to pull a negative out of here, but you can pull a negative out of anything, and I'll show you. Because we're trying to cancel a negative, it actually helps to pull out a negative 11 from the top. So we know 11 goes into 55 and 44, but so does negative 11. We just have to multiply by another negative to get a positive. So we're going to actually pull out a negative 11, so it ends up canceling. That's the only reason we would do it, so it cancels. We've got y's. We've got 2 in both, 3 in this one, but 2 in this one. And over here, you got z, and the most I can take is 2. You'll notice that's exactly what I have here on the bottom. So that will end up canceling. Now, to get a 55 from a negative 11, I have to multiply by negative 5. And then I already have y squared here, so I just need to add some z's. I need 3 more, so z to the third. To get to a 44, positive 44, I need to multiply by a negative 4. Negative and a negative gives me positive 44. And I go to y to the third, so I need 1 more y, and the z's are just going to stay. So I'm looking at this. These are going to cancel. Final answer is negative 5z to the third minus 4y. So technically, if you had just taken out the 11, you would have been able to cancel everything down here, but this negative would have stayed. If you just took out the 11y squared, and then you would have had positives in here, but you would have been left with a negative 1 on the bottom. And when you divide by negative 1, what happens? The numbers and stuff don't change, but the sign will change if you divide by negative 1. So you would have had a positive 5z to the third plus 4y, but it would have been over negative 1. When you divide by -1, it would change to this. So you could do it the other way, but if you pull the negative out, factor the negative out, it will just help you get there a little smoother. That's all. Okay, so as I look at this, I know I need to pull a 3, and that's the smallest number up here. So 3 is coming out. All of them have an A. One has just 1, so that's the most that I can pull out. And that'll cancel the bottom. And so to get to 18a squared, I need a 6a. To get to 27 negative, I need a minus 9a to the 4th. And then to get to another 3a, I just need a 1. These cancel. Here's your final answer. That's what's left over. Over here, I'm going to pull that negative out again. So I'm going to pull a -6. They all have b's. 3 is the most that I can take out. And again, you can almost start to cheat here on these problems and see this is what I'm going to factor out. Let's see. Got to multiply by a negative to get a positive. 5. Don't need any more b's. Need to multiply by a -7 to get to 42. And I got to go from 3 to 7, so I need to add 4 b's. And to get to a negative, I'd actually multiply by a positive here. To get to 54, it'd be 9. B to the third becomes b to the fifth, so that's b to the second. This all cancels, leaving me -5 minus 7b to the fourth plus 9b squared. All right, over here, I'm going to cheat here, and I'm going to take an 8 out. C squared is the smallest of the c's, and then d to the third is the smallest of the d's. That will end up canceling here on the bottom. And let's see what's left. 8 times what is 64? That's 8. C to the second became c to the third. I need one more. I need one more d as well to go from 3 to 4. Need a negative times 7 to get to 56. Don't need any c's. I need 2 more d's. To get to 40, I'm multiplying 8 times +5. I need 2 more c's, and I don't need any more d's. This cancels, and again, here's my answer.